Well, thank you for joining the webinar this afternoon, and I hope that you'll find some information that we go over useful. Today, what we'd like to go over is we'd like to talk a little bit about the sample loading in both normal and reverse phase. Obviously, there's two ways that samples can be loaded onto a flash chromatography column. One way is with solid loading, where the sample is introduced as a solid, and the other way is using liquid, where the sample is dissolved in some liquid. So we're going to talk about how that's accomplished in normal and reverse phase. We're going to talk about some of the things you have to be careful of when using both liquid and solid loading. When we talk about solid loading, one of the things we'll talk about is we'll talk about the solid load cartridge. Solid load cartridge, you can see here, is this plastic tube. This one happens to have some material in it, some media, like silica gel. And then this is actually the cap that is commonly referred to as the solid load cartridge cap. The way this device works is this Teflon seal goes down into the barrel of the syringe, and this stainless steel piece rests at the top, on top of the frit that's holding this media in place. The cap up here has several grooves on the shaft, and this lever is pushed in to release this cap to move down to where it sets, and then is rotated so that it fastens onto the ears of this of the cartridge, so that it's held in place and can be pressurized. So, for various size solid load cartridges, there are various caps available where the diameter of this Teflon tube is appropriate to fit snugly in the barrel. Obviously, over time, this Teflon wears and will have to be replaced on the solid load cap. So that's some of the things to be cautious of, and it's typically very easy to see because you'll see liquid flowing back up and around the stainless steel plunger here, and you'll see the liquid behind this seal. That's a good indication that the Teflon is deteriorated to the point where it needs to be replaced. So first of all, let's talk about comparing sample loading techniques on silica columns. And all of our examples today, we're going to be using this reaction, which we do here in our lab. It produces a good mixture. It gives us some starting material and gives us some finished product. We've also standardized some things. So all of the runs use our standard solvent method on an RF200. When loading a ReadySep column into our system, it automatically identifies the stationary phase and the size of the column. It establishes a gradient based upon the solvents that you've selected. And so that gradient profile is what we're going to use in all of our examples from a chromatographic standpoint. We're also going to use 2% sample load for all examples, and we're going to use hexane ethyl acetate for all of our elutions. So we've kind of tried to standardize all of the functions, as many functions as we can. First, we'll talk about solid loading. Two different ways to solid load. One is with user-packed solid load cartridges, and another is with pre-packed solid load cartridges. So a variety of the flash chromatography companies that are in the market today, they offer both what's commonly referred to as empty solid load cartridges, which I've referred to as user-packed, and pre-packed solid load cartridges that come in a variety of masses of silica or Celite or other materials. So the user gets to choose what is the preferred method. And so what you see here is you see some empty solid load cartridges, and then these down here have silica media or some other type of media in them, and you can see that there's quite a range of sizes, everywhere from about a 5-gram column up to a over a 65-gram column. So there's a wide variety of cartridges that can be used for solid load, depending upon what your separation column size is. Over on the right is a photo of the of our RF200 with the purification column in place, and then the solid load cartridge positioned above our injection valve. Let's first talk about this and break it down a little further into user pack solid load cartridges. Fairly simple to make this up. You simply weigh out your sample, and based on the amount of sample that you have, that determines the amount of sorbent that you want to use. In the case of, we're talking about normal phase at this point. We'll go through this again with reverse phase. But in normal phase, typically you would load 20% load for silica, 10% for Celite. So you take your sample weight, you multiply it by 4, and that's the grams of silica that you would weigh out. If you're doing Celite, you'd multiply your sample weight by 9 to get the amount of Celite that you'd want to add into your sample. The first thing you do is you dissolve your sample up completely in mobile phase, or actually in any type of solvent that it's highly soluble in. You add the media that you've weighed out, you mix that together, and then you simply dry it on a roto-evaporator. Once it's dry and looks basically like the dry silica that you started with, then that mixture can be placed into the cartridge. You then add the top frit onto the cartridge, tamp it down, and then insert the solid load cartridge cap that we had a photo of just on the last slide. What you see over here on the right is something that sometimes happens where the sample will, during the drying process, will bubble up, especially if you're running your rotovap slightly high. What we've found here is that if you take our frit that's for our 5-gram solid load cartridge, it generally fits nicely into this adapter, this 2440 adapter that's we find in the United States. The benefit of using this here is then that keeps the adapter and the rest of the roto-evap from getting contaminated with your sample. Sample can easily be washed back off of this, back into the round bottom flask that you have your material in, and continued to be roto-evaporated and dried. One thing I should say before I move on from this slide, let me back up to it, is that if you exceed these loadings, these are suggested loadings, but if you exceed the loading, you end up with particles of your sample that's not adhered or absorbed onto the surface of the silica or Celite. As those particles, what happens when you start doing your chromatographic run, those particles start to dissolve, and that leads to, it takes time to dissolve, and so you end up with lost resolution or poor peak shape as that material dissolves, as it moves through the purification column out of the solid load cartridge. User pack solid load cartridges obviously give the best resolution. The reason for this is because you can pack the solid load cartridge with the same material that's in your purification column. So that way you're essentially just extending the column bed up into the solid load cartridge. You can match your sample size to the silica. It allows you to use strong solvents. In other words, if your sample is not so soluble in hexane, you can dissolve your sample, and very soluble in ethyl acetate. You can dissolve it in the ethyl acetate, even though that's the strong eluter, because you're going to roto-evaporate that ethyl acetate off and start your gradient run from hexane. And as the solubility of the compounds increase, as the solubility of the compounds increase as the gradient gets more polar, and so it elutes off in fairly narrow bands. The other thing it can do is it can act as a pre-column. So if you've got material that isn't soluble, that stays on the solid load cartridge and does not move into the purification column. Sometimes with liquid loading, you find that the sample does what we call crash out, where it precipitates because it might be dissolved in a stronger eluting solvent, and then when it's hit by the nonpolar solvent, the compound's not soluble at all, and so it would precipitate out at the top of the column. You'll see this as a clog, where the pressure increases to fairly high pressures at times, sometimes to the point where the system either has to shut off or lower its flow rate till the clog is redissolved. So using user pack solid load cartridges, that's prevented. As I mentioned earlier, these are also called empty solid load cartridges. The other option for doing solid loading is to use pre-packed solid load cartridges. They go through the same thing. The sample, you dissolve the sample, you add it onto the solid load cartridge, and so you would do essentially just place your material on the top of this, and you can dry if you desire. One way to dry is using a vacuum dryer, such as this one that you see in the picture. Another way is to use a vacuum oven and place the cartridge with the sample and the solvent that it was dissolved in a vacuum oven for some period of time to drive off the sample drive off the solvent that your sample was dissolved in. And the last thing, after you've dried it enough to your satisfaction, then when you think all of the solvent has been dissolved or evaporated off, then you simply insert the solid load cartridge cap again, and you're ready to go. Again, you gain the advantage of the fact that the cartridge acts as a pre-column, and so it removes, totally retained material stays on the solid load cartridge, and you maintain get some extra column length due to the extra silica that's in the solid load cartridge. Well, these are two examples of what happens when you've got your sample dried on the cartridge. In this example that we have of this reaction mixture that we showed you earlier, you have two major components. You've got some 3 minor impurities that come off. And if you collect peak 1 and peak 2 here, and you look at the HPLC trace, you see that those are very, very pure, and we've managed to cut out the impurities both before and after the two major components. So that's when the sample is dried on the cartridge. If you don't completely get the sample dry, you still have some of your solvent that you had the sample dissolved up in left on the cartridge. You'll see that you get very strange peak shapes. You get poor resolution. And if you do a purity analysis later, you'll see where you've got some contamination where this peak here came out, was collected in with this peak 1 fraction, and the peak 2 fraction has some of these later eluting components come out in it. So poor resolution. So if you get some of these very different looking peak shapes, one thing that you might suspect is that you didn't completely get your sample dried on the cartridge, and so if you had a polar solvent that you were using for the introducing the sample, then that's caused a shift in the peak shape. Liquid loading. Let's talk a little bit about it. Liquid loading, we can see where we've got this reduced resolution when the sample is dissolved in a strong solvent. So liquid loading, it becomes really important that the sample be dissolved in as either one of two things: a small volume of the strong eluting solvent, or preferably in the least polar or the weakest eluting solvent that in your system. In either one question that's always asked is what the effect of air is in a solid load cartridge. And this is an example. I know from HPLC, I know people were always cautious about getting air into the column. That would dry the column out, would affect your separation. That is really kind of something that's not necessarily the case, especially in this flash chromatography. And what we see here is we see two traces where the red trace, we didn't remove the air from the solid load cartridge before the sample was introduced into the flash column. And the blue trace where the air was removed by pumping the cartridge with our non-polar solvent after we'd introduced the sample, so that the air in the cartridge was actually not pushed onto the purification column. You'll see that there's essentially no difference in the separation here. You don't see additional peak shape issues that come up that's contributed to the air, so there was really negligible effect of the air on the purification column that was used. Okay, so that's what we've covered in the normal phase. We've talked a little bit about the solid phase loading or solid loading. We've talked about liquid loading. Let's talk about comparing those two techniques in the case of C18. In this case, we're going to use the same reaction mixture. As an example, all the purifications we ran in 35% water acetonitrile isocratic with a gradient to 100% acetonitrile at the end of the run to wash off the column. We used the same column. One of the things that we haven't talked about is the fact that normal phase columns tend to be a single-use column where they're disposed of after the purification. In the case of C18 columns, they can be used multiple times. The one thing that you'll see here is that we have the same column loading of 1% load, because you can't load as much material on a C18 as you can on a Silica normal phase column. But we've used 1% for all the runs so that we can get an apples-to-apples comparison. Again, C18, same thing, user pack solid load cartridges or empty solid load cartridges, as well as pre-pack solid load cartridges are available from most manufacturers. Very similar to the user pack solid load cartridges. And there is really a mistake on here. In this case, I've got a 20% load for bonded, it says bonded silica. So I didn't see the bonded there for a second. But anyway, you can load 20% just like onto whatever phase of sorbent that you're using, or 10% for Celite. So same thing, again, 4 times the sample weight for the amount of sorbent if you're doing bonded silica, and 9 times the sample weight for the amount of Celite that's needed. Same thing, dissolve the sample completely, mix it with add the media to the flask, dry it on the roto-evaporator, place it in the cartridge, put the top frit in, and again insert the solid load cartridge cap down to where it's on top, meets the top frit. For pre-packed Celite or C18 columns, very similar to normal phase. You dissolve the sample, you add it to the solid load cartridge, like you would do. We're doing a liquid injection. You dry it if you desire, either using a vacuum dryer or the vacuum oven. Insert the solid load cap, and you're ready to start your purification. C18 pre-packed solid load cartridges are also something that's available from most manufacturers. In this case, before loading your sample, you need to condition the C18 solid load cartridge by washing with an organic solvent followed by water. As a rule of thumb, you use 2 times the mass of organic that the cartridge holds. So if you're using a 5-gram cartridge, you'd use about 10 milliliters of your organic followed by 10 milliliters of water. So 2 times the cartridge mass to condition the column with organic, cartridge with organic, and then 2 times the cartridge mass of water to get it back to where you don't have a non-polar or high strength solvent in the cartridge when you start to do your chromatographic run. And down here below is a used pre-column, and you can see, or pre-cartridge, and you can see that it's obviously extended the life of your preparative column because there's material that's been trapped on here that's not eluted off of the C18 material in the cartridge. We didn't really worry about this so much in normal phase since it's single-use columns. However, in the case of C18, where you can reuse the columns multiple times, and the number of times that you can reuse it is a function of both the mobile phase that you use as well as cleanliness of the sample, this does become influence the number of times that the column can be used. This is an example of a solid load cartridge packed with Celite. Celite's a type of silica, but it has reduced absorption and binding when compared to chromatographic silica. Water is a weak solvent for C18, but it's a strong solvent for silica, so compounds elute quickly off the Celite material and then become retained on the C18. So you've got your sample that you've added onto Celite. You've dried the Celite as much as possible, and you introduce water as the reverse phase, first solvent that you use in the reverse phase gradient, and so the compounds quickly move off of the Celite because it's a strong eluter from Celite. Then it becomes a weak eluter on C18, so your sample is actually introduced in a very narrow band onto your C18 column when using Celite in the solid load cartridge. Again, people concerned about the effects of air in a solid load cartridge. Here we can see the run where the air was not displaced, and here on the right is the run where the air is displaced with water. And in this particular example, there's a little bit of change in selectivity here at the very beginning, but the retention times of the peaks, 10 column volumes for this peak, second major peak, compared to 10 column volumes here, and even the peak shade is the same. So you can see that the air is not something you need to be concerned with, and you don't need to spend time trying to get the air out of the cartridge before introducing your sample onto your preparative column. Again, you get very similar influences when, if you've got your sample dissolved in a minimal amount of strong solvent. In this case, it would be your organic modifier. So you get a very good separation. It's actually very close to the separation you get here, where this has been dried completely. So you don't get a lot of loss of resolution. However, if you've dissolved the sample in a significant amount of strong solvent, or the organic modifier in the case of C18, you'll see where you've gotten a decreased resolution and undesirable chromatography. So your purity of these two peaks will probably not be to the standards that you'd like to have seen. Okay, liquid injection onto a C18 column. Simply sample load onto the column. It typically 1 to 2% compound mixed based on the resolution. So the poorer the resolution that you see, especially if you run a reverse phase TLC plate prior to sample loading, the lower the percent compound mixture can be. And just a side note that diluting the sample in a large volume of the weak solvent is much better than a concentrated sample in the strong solvent, because the column will capture the compound in the weak solvent, and it won't migrate down the column. It will stay as a fairly narrow band at the head of the column until you start introducing sufficient organic modifier to cause elution to begin. A lot of people like to use liquid injection onto the column. One reason is right here: fast and easy. Dissolve your sample up, inject it onto the top of the column, and start immediately. You can start your purification run. And the thing to just be aware of is that you need to make sure that you have your sample dissolved in a minimal amount of the strong solvent. You can get good resolution. Too much strong solvent, and you start to see your resolution deteriorate, like we see in this example on this slide. One really good illustration, I believe, of liquid injection is this vitamin B12 sample. In this column here, you'll see where the column is discolored almost from top to bottom. This is where the sample was injected in 1-to-1 methanol water, and you can see that the sample was essentially dragged down the column after one column volume. So what you see in the purification step is you see this fronting here, where some of the material that was early eluting came off. You'll also see that you've got some material here that came off in 1 to 2 column volumes. Well, that's material that moved down as the methanol moved down the column, and it carried some of the B12 with it. This is the chromatographic column, same as this one, only where we've injected the sample in water. And so the sample is actually setting at the top of this column after it's been injected. You can see down in the bottom photo, you can see where the band is moving down fairly organized, and it's not streaking down the entire column body like it is here. what you get as a result of that is you get a very nice sharp peak out of the flash system. And so you don't see the fronting, you don't see these early eluting peaks because everything's held together in a nice tight band and until the gradient conditions reach the point where the compound starts to elute off the column. So just for a commercial break here, just wanted to go through the RF family. We have a wide variety of products ranging from the RF75, which is a low-cost system, through UV, UV-Vis, and the 200i, which has integrated evaporative light scattering detector. And for scale-up work, we have the CombiFlash Torrent, which is up to 1 liter per minute, 100 psi of sample or pressure, and up to 300 grams of being able to purify up to 300 grams in a single run. And the last thing is that all of our systems are compatible with the iPod, the iTouch, the iPhone, so that you can remotely monitor what's going on the chromatograph while you're away from the lab and it's running a sample. It pops up any error messages or user alerts that, and you can see those and take appropriate action. Please keep in mind we have a free guidelines and tactics for flash chromatography that covers a variety of things such as solvent selection. My contact information is there. You can get our guide simply by going on the website www.isco.com/flashguide. There's a little form to fill out that gives us your mailing address, and keep in mind we will be having some additional upcoming flash chromatography webinars listed down at the bottom. Purification of compound classes, a look at alternative media such as diol, cyano, etc., and a basic course in Introduction to Flash Chromatography for those that are not familiar with flash. I'd like to thank you for your time today. Appreciate the questions and the interest, and I hope everyone has a great day, and hopefully the chromatography goes well. You get absolutely pure compounds that don't need purification. Thank you very much.